But more importantly, I will, more importantly, I want people
Yeah, we have already used that.
to know, A, if they're considered or compliant, so they're informed, speak up on the rest. And also, if you know that people do not have to speak it, because what do you want to do? Apparently, only use every how and going on it. They so far everyone said the two, they can fly. The other things, so we can get to all the communities and also
It's not so friendly. It's not so friendly with the PowerPoint. We must firstly convert it to the Google format. Save it as a Google file.
Or use your own computer.
Yeah.
Chris and I were using it all day.
I haven't even read it all the way through.
Do you also have it? Yeah, yeah, yeah.
But the bottom line is people are using it, and we are supposed to document protocol and we believe it to be then,
CCIE.
25 years.
yeah, man. Can you dispute it?
Oh, yeah, I had some.
Oh, no, you misread.
I can have some issues where like the CCI points out, so like 10 years back, I did not get.
Okay, that I can't really, that, I was just going to dispute if you were saying CCIEs are excellent. I'm saying the program, but you just, okay.
Yeah, and I didn't kind of 10 years back with the whole thing. I sent some email and they were like, oh, yeah, not about those, so I guess it's just like,
That sounds okay. No,
and this would be that 2019,
yeah, this is our out. No,
2093?
yeah,
Okay, I wasn't sure that the first 2 years were like.
no. I started, this is, I have it, but this is also my group, so I thought, my group, and then the learning there. Well, what was until August.
I can never remember EX data
Development kit.
development. I always try to do the EX data catalog. Catalog stuff.
That's because we're leaving. Okay, game development.
Okay, next one.
Yeah, next year, excellence is all off.
So,
Oh, we live. Oh, yeah. You want to kick us off?
Hello, everyone. We will start the meeting. Okay, Warren, go first. Go, Warren. Go, Warren. Go. Hello, everyone. Welcome to the joint Ops area and Ops AWG meeting. The first session is Ops AWG meeting. It's chaired by Tianran and Joe. The note 12, please make sure you understand those important legal issues. Basically, all your contributions need to follow the IETF rules. And the blue sheet is circulating. Please write down your name. And before we can really start, we need a Java scriber and a minutes taker. Is there any volunteer?
Really, we need a Jabber scribe, and anyone who wants to go to the minutes Etherpad, we can always plug in minutes there. So I encourage multiple people to do that, but we do need someone who can log into Jabber and act as our Jabber scribe. Someone with Jabber. Anyone? Jabber. We do it, but mine is not working. Sounds good.
You wait one. Okay. So we use the Etherpad so everyone can help to take notes. Thank you. And the working group status. Since last meeting, the Cat Web alternate tunnel draft has been published as the RFC A350. Now we have 4 active working group documents.
Indeed. Okay, so first off, MUD, manufacturer usage description. That is moved along quite well in the IESG. So it's currently sitting in the RFC queue in a misref state, and the reference that's missing is the ACL model from NetMod. I talked to one of the authors of the ACL model. That is currently, there are 2 IESG comments that are getting taken care of. He's not expecting any of those changes to be held up too long, nor is he expecting any of the changes to cause any disruption or change to the MUD, the current MUD work. So we expect that, I'm hoping, very soon, like next month, we should see those go through. But that is the current, there's nothing other than the ACL model gating MUD. As for the IPFix BGP community, we are waiting for a Shepherd write-up on that one.
Is there any volunteer for the Shepherd in this room? Okay, we will find someone offline. Yeah.
With regard to the NAT Yang module, that has currently been sent to the IESG, and I just heard from one of our ADs, Ignis, that it will be proposed to the next telechat. Whether or not it makes the packed agenda, we'll see, but it is currently slated to be discussed as soon as possible by the IESG. Saving the best for last, we'll go on to the next slide, and this is the status of the TACAX Plus draft. Fortunately, we've gotten a lot more author engagement very recently on the list. The current work right now is focusing around the security considerations text. In particular, what we're trying to do is shore that up so we can recommend how best to secure what we generally consider to be insecure. So just as a summary, the draft scope is to document the TACAX protocol as we believe it to be implemented today. This is an informational draft of TACAX Plus as we believe it to be implemented today, with no additional extensions or anything like that. We want to give recommendations to people deploying TACAX how best to do that, and we want to give recommendations to vendors or implementers of TACAX Plus clients and servers what they should do if they are going to create a new implementation or update existing implementations. We believe it is close to a working group last call. There is some text that the authors want to add in, but after that I will call it, or we will call it on the list to make it formal. There is a big pending question, and I want anyone who is a vendor or implementer or knows a vendor or implementer or has ever talked to a vendor or implementer, comment on the list, specifically to what's written there. If you know of or you are responsible for implementations of TACX Plus clients or servers, are they compliant or do they adhere to this draft? If they do, great. Just say, yes, I know of this implementation, it adheres. And as importantly, if you know any that do not adhere to this draft, what are those implementations? Where do they deviate from what is being documented? There's also some related work to this that will be presented Friday in NetMod around a Yang module for doing TACX Plus configuration. Given that there is a correlation between that and this draft being worked on here, if you have comments, it would be good. The authors, I know, would appreciate it to be able to go to NetMod on Friday, listen to that, and certainly comment on the NetMod list. Comments?
Yeah, Michael from Huawei. I speak at TACX Yang modules co-author. Yes, we have applied TACX Yang module in NetMod working group, and we also will present this document on Friday's first session. And as I know, our company, Huawei, has implemented TACX Plus, and we provide Yang this module to introduce how to reconfiguration the TACX on the system client. So if you have interest in this topic, please to join our discussion, and comments and suggestions. We are very welcome. Yeah, thank you.
Speaking of which, thank you very much. But speaking of which, do you know that Huawei's implementation is compliant to this TACX Plus?
Basically, it complies with this, but it still have a little different. But we can discuss it. Okay.
Please do so on the list.
So Warren Kamari, I have written in the past 2 client implementations. I believe that both of them comply with this, but they were a long time ago. And one of them was at AOL, where I no longer have access to the codes tested. So I think that they comply. I don't know of anything where they don't.
Next here is the OPSAWG agenda. We have 4 presentations. Is there any agenda question? Okay, let's start the discussion. First one, the network telemetry framework. No, it's not work.
Can you hear me now?
So good afternoon, everyone. Today I'm going to present this our draft toward a network telemetry framework. Actually, this is the second time we are talking about this. So first, what's new about this new revision? Firstly, we have quite a few contributors. We have co-authors from TI, from China Mobile, NICT, Nokia, and China Telecom. Thanks for these co-authors' solid contribution to make this draft better. And in this revision, we make a clearer definition and characteristic summary of network telemetry. We intentionally make a clear distinction between the conventional OEM and telemetry, and also propose from now on to use telemetry as a standard word for the technology to achieve network visibility, so they can support meet today's network challenge and also address future networks requirements. And also to complete our framework, we add a new module to the framework, which is external data and event telemetry. Also, in the old version, we have only control plane telemetry, data plane telemetry, and the management plane telemetry. So these are all belong to the network. So we feel it's also necessary to add another data source from outside of the network to make this whole framework complete. And for the control plane telemetry, we identify some requirements and the challenges for the control plane. And we add the BMP protocol extensions to name it as a NIP. I believe Robin for the next talk will talk about this. And we also add new content for the data plane telemetry. First, we try to classify all the existing different type of technologies. So the classification can be done from multiple dimensions. For example, we can do the active and passive telemetry, in-band and out-of-band. In-band also means, here we use the term in situ, means telemetry data will be carried in the user traffic. Out-of-band mostly means we may inject some dedicated probing traffic. And also the E2E and the in-network. E2E means the telemetry data or the instruction may be initiated from the end host and collected from end host. And in-network means the data is only generated and consumed in network. The end host will not be aware of it. And also there could be multiple sources of the collected telemetry data. It may be belong to flows, or belong to paths, or belong to the node. So we use these different dimensions for the classification to classify different technologies. And for the specific technologies in this new revision, we give some brief introduction to some new technologies, including the IP-FPM. It's used alternative marking to support different type of performance measurement. It now can be done point-to-point or multi-point to multi-point. So the related drafts are referred from this draft. So now I will talk a little bit details about the draft. Firstly, we believe there are a lot of visibility challenges for today's network. Regarding the overall goal to simplify the network operation, actually we see today's network become more and more complex because there are so many different type of networks and so many different protocols are introduced in network. And nowadays, customers are more and more concerned about application level performance. Because, for example, they want to learn exactly how their application or service traffic experience in the network in terms of the bandwidth, latency, jitter, packet drop, the reason for the drop and the drop rate, and also what's happening in the network. And we see the network visibility is extremely important for different purpose, for the normal network OEM, for network configuration and provision, for long-term network planning, security, and the troubleshooting. Yet we don't have very good tools today to meet these challenges. For example, nowadays we still don't have very good tools to achieve the good application level visibility. And also, all the tools involve a lot of human labor. We don't have enough automation tools to automate the process. And if we look for the future network architecture, we see today the artificial intelligence has been introduced into the network. And we can foresee that in the future, network management will be mostly handled by the machine instead of a human being. We call that can be intent-driven autonomous network, in which we significantly reduce any human labor involvement, and we can improve the network agility and the performance. Also, we can achieve the best optimized resource utilization. So that's if you look at the network architecture, we form a closed control loop. On the one hand, we just extract all the enough data to gain the enough visibility to the infrastructure, and based this visibility, we can apply the policies through the programming way to do that. So in this architecture, network visibility is just a pillar of that architecture. So we believe that telemetry should be promoted as a first-class citizen in network technology and the protocols. Also, there is a need, since we will have a single brain in this network architecture, and we believe that all the network telemetry work should be unified and consolidated, and also integrated to support the future network. But the current OEM-based solution is insufficient and inefficient to sustain the future autonomous network. For example, today we are still using the SNMP. It's based on the very low frequent polling of the data from data plane, and this is done through the command line interface. The data is lack of coverage, timeliness, and accuracy. Also, we have many different tools. They are all disaggregated. We have many piecemeal vertical solutions, and it's very hard to be composed into a cohesive solution. And once we have a new protocols and new architectures, we'll come up with a new OEM solutions. Some of the work is repetitive and redundant, and there's a lack of collaboration and consolidation. And in many cases, the OEM work is just designed as an afterthought when the basic protocol is done. So there's lack of a holistic and systematic view. So we believe a new brood of technology is expected. And therefore, we need a framework to normalize the concept, the terms, and the technology standard development. And therefore, we propose to use telemetry as a standard term to replace OEM for network visibility.
10 minutes.
Okay. So here is we try to list the detailed difference between the conventional OEM and the network telemetry. So the left side, the yellow blocks are mainly the characteristics of today's OEM technology, and the green blocks are mainly the features of the future or the current network telemetry characteristics. So, for example, for the conventional OEM is mostly for the distributed network architecture. But telemetry is mainly for the SDN-based architecture. We assume there's a central entity will oversee the entire network and also apply the control to the network. And the data for the telemetry, the data should be pushed from the network to the data collector or data consumer. But for the OEM, we still use the pole-based, so it's low frequent and also low throughput. And since the data is pushed, we can use the streaming data, which means the data will be continuously sent to the collector. So this is another important feature for the network telemetry. And also the data quantity is huge, and there's many target for the machine to consume rather than for the human consumer. And this whole process for network telemetry is automated, and through some programming means to configure what data will be collected and how the data will be exported. And based on the data analytics, we can the telemetry can do the prediction rather than simple troubleshooting of the network. And finally, this telemetry architecture should be unified, and many data sources can be correlated automatically. And for the conventional OEM, so far we still have just independent tools. There's no very hard to do the data correlation. So on the right-hand side, we list several existing protocols and open source works. Those can be considered which bear most of the characteristics of the network telemetry. So they are very good candidates for the network telemetry framework-based technology. So this slide shows what the framework look like. On the left-hand side, you can see for network, we will have a control plane, manage plane, and a data plane. So each plane will provide its own telemetry interface to the network operation applications. And between these three planes, there could be some other interface for the information and the data exchange. And outside of the network, we'll have external data and the event telemetry modules to provide the data to the network operation applications. So in the draft, we provide a use case to show why this is necessary. And for each of this plane, we can further partition the telemetry into 5 components. The first is data source, which covers where the data comes from. And the data subscription covers how the application will subscribe the data. And the third component is data generating and processing. So it covers how the required data is generated and pre-processed. And finally, is the first component is data export. So the generated data will use some interface to export the data to the target application or the collector. So the last component is how the data will be analyzed and stored for future use. So in this figure, we list some representing technologies. Some are still in the research stage. Some are more mature in IETF. So this provide a good baseline for the related work.
5 minutes.
Okay. So yeah, I will skip through this slides. Basically, we can see the telemetry has many important use cases in network. In addition to the conventional use cases, now we can see that telemetry can also do the intent and the policy verification. So based on this verification, the intent engine or the intelligent engine can be sure their policy is correct. And so this is an interactive process. You will need to continuously collecting data from the data plane and do the analysis and then push the updated policy back. So this forms a closed control loop. There are many challenges for network telemetry. First is dynamics, because data need to be continuously collected, and we need the data to be real time, and the process is interactive. So it's challenging to provide such a interface, and also from both sides, data plane capability, also how the control plane interact with application. It's both very challenging. And the data could come from anywhere. It can be from a device, network, and even out of the network. And also the data source can be passive monitoring, can be active probing packet, or the hybrid technologies such as Institute OEM. And so it's need to correlate the data from multiple sources. It's also very challenging. Finally, there's a performance impact. Because most of the data can be directly extracted or pre-processed in data plane, it creates some performance challenges to the network data plane to achieve the ideal bandwidth and the latency. Also, the huge amount of data need to be stored is also challenging. And we don't want this telemetry technology to interfere with forwarding performance, which is called observer effect, because the visibility is important, but the first priority is still the high performance forwarding. So we don't need, we don't want to interfere with that. So to recap, we like to promote the significance of telemetry work in IETF. Keep in mind that this mainly address the future intent-driven autonomous networks requirement. We'd like to make IETF the leading standard organization in this area. Also, in this draft, we try to formalize telemetry-related terms and technology classification in IETF. So there are many different other names such as network measurement, troubleshooting, monitoring. So we believe all these are data-oriented and serve for the network visibility. So they should be all covered by telemetry. We want to consolidate all the existing work and make this framework to guide the future development. So of course, we continue to call for more collaboration from the operators and the vendors. Thank you very much.
Any
Any question?
So, just a comment from me, or a question really. Your last thing there is call for collaboration from operators and vendors. What is the goal you have with this draft? What is your intent with taking it forward here? What do you believe? I mean, you're not asking for adoption at this point, and I think there is some work to do on it. But what is your goal concerning this draft?
So our initial goal is, try to formalize the terms, try to achieve some consensus on the, what we really mean about telemetry and what's this difference from the OEM. And also we want to give a survey of the existing IETF work, and so we can gain a better understanding. So what's the gap? But for the next step, whether or not we need to develop new technologies, or just work on the existing ones, or improving the existing ones, we don't have a very solid idea yet. So first, we want to gain feedback from the community, whether or not this work is meaningful. And then we can come up jointly come up with a goal. So what's the next step? If we need new technologies, what's the real gap is, and or we should work on the existing ones. If so, what are the candidates?
Rüdiger for Deutsche Telekom. Well, okay. Let me try to turn the words you used a little bit in your mouth. What I'm hearing you say is you want to map the area of what is around, and well, okay, terminology and so on. And you claim that some new technology is needed. I think getting a better understanding of the environment in which one is operating is always a good thing. Taking conclusions about how to change that environment actually should be considered after you actually have established that better understanding. And so kind of if you split the activity of mapping out what the problem space is and what available technologies are, well, okay, that's good. And I have no opinion on whether that is really a missing thing. But, well, okay, kind of doing this with the claim that something new is needed for an environment that is not fully that is not explained in a way to fully understand. Well, okay, that's a claim that is a little bit premature. Okay.
So I have mentioned we are targeting this kind of future network. So can anybody say this is already solved or supported? I don't believe anybody can claim that. We are still very far from that. So what's missing here? We may all agree that telemetry is a very important component here, but I don't think today's technology is ready to support this kind of network. So that's why we try to identify what's missing, what's the gap, how we can achieve that. I believe ultimately in the future we should achieve this.
This is Alex Clem. One question, actually, I have, or one comment is that why I don't disagree with any of the statements of thought that you're making, but concerning this particular work, I'm wondering actually really how broadly or how narrowly you want to frame it. And I find something actually a little bit confusing in the sense that you talk about telemetry, like framework for telemetry. Telemetry clearly is a part of providing network visibility, not the only part of visibility, because in addition to telemetry, you have events, for instance. I'm not sure if they would categorize as that. And then later you talk also about even intent and all those things. And intent, to me, this goes into beyond just assurance and visibility. It goes into how do I fulfill services. So it becomes perhaps a little bit too broad. And I think as a problem statement, it would be good to confine it more clearly.
Maybe I'm not very clear here, but I mean only talk about the very right arm telemetry, because for the intent, it's actually the control path. So you instill this to control the infrastructure. But after that, you need to verify if the policy is working correctly, or to do some SLA verification, then you need to collect data. So
Sure. So I think there are going to be other activities and also various use cases for which telemetry data is useful.
yeah,
I think that would be pretty good with this. Also, you call out, actually, I just noticed here, you have network analytics here, right? So network analytics, that would be something that is being fed
yeah.
by telemetry.
Yeah, so I agree. It's a very, very broad, and also many existing technologies are mapped into this figure.
So my comment would be to be clear if we wanted to be a telemetry framework, or which would be more narrowly than if you have some larger assurance framework, which includes a lot of the other things that you're mentioning.
Okay.
Okay, time's up. And next, the NMP, Network Monitoring Protocol.
This is Robin from Huawei. This topic is network monitoring protocol, produced as the NMP. In fact, this work has much relationship with the existing BMP work, but in fact, it's not determined which working group should it belong. So that we present this work in both OPSA, WG, and tomorrow's Grow working group for more comments, to solicit more comments. Okay. So this is just the overview of this the existing work we do for the network telemetry framework. So here, for the past years, we have do a lot of work related with management plane telemetry. And also we do a lot of work related with data plane telemetry, related with in-band OEM, etc. Managed plane is young, netconf enhancement, gRPC, etc. But in fact, from our point, in fact, we also need their existing use case. We need to monitor the control plane. So that's we think. So here we promote this NMP. So this is the purpose for this work. So this is the motivation and the brief introduction. So now that is the control plane monitoring, especially this is the monitoring running status of a control protocol enable the solution towards automated network OEM. So the second one, that's the NMP is proposed to collect the protocol running status, including the protocol packets and the protocol statistics, and export the collected data to NMP monitoring station for analysis, which will facilitate the network troubleshooting. So in the current version of the draft, so this is the early phase. Firstly, we propose this the NMP for SS as the use case to show the necessity of the NMP. But later, that is this work may be extended for other control protocols. So here, this is the use cases. In fact, based on our experience for the troubleshooting for the network, there are many use cases related with the control protocol. So here we give some of these use cases related with the SS. In fact, the IDP is very, very important, control protocol in the network. And also because of its the flooding characteristics, once some failure happens, it may affect the whole network. So that's to some extent, it can become a disaster
for the network. So here we list some of these the use cases. The first is the SS neighbor DOM. Based on our internal statistics, almost 50% of these failures related with this the IDP neighbor. So that's is a very important cases for us. Also, there are the different reasons. So that's maybe the most important, the mismatched parameters. So that cause this the neighbor DOM. So this is also the neighbor DOM can cause the subsequent outcome, make the root is flapping. So this also is very important. Second is the RSP synchronization failure. So this is so that's the packet is sent, but the neighbor cannot pass the packet correctly. Or this so this is called the synchronization failure, etc. And also we have this the forwarding plane disconnection. So this is, for example, proposed in the draft is match the PTU, MTU, because sometimes we use that the pin for this forwarding plane. It does work, but actually for the actual user traffic, it does not work because of inconsistent MTU. So this is also can be export some information to locate this failure. And the next one is the root flapping. In fact, the root flapping has a lot of reasons. The neighbor DOM is the one possible reasons, but in fact, based on the experience learned from the network, there are so many other reasons. So this, to some extent, to pass the protocol packet, to some extent, can solve this issue quickly. Okay, so now that's the existing troubleshooting of the methods. So sometimes we use the CLI to log in the routers and to check each router one by one. So this is time consuming. And also sometimes even when check, you must to comparing a lot of information manually, because because the number of the root or the root packets is huge, is difficult. So this also the labor consuming. And also this the data acquisition difficult. Yeah, and also that's in some of the cases, the root flapping. So that's in some issues and the failures change at the time very quickly. If the time consuming and labor consuming, when we found some of these clues, but it will change immediately. You have to locate again. So this is also this challenge for the existing troubleshooting methods. So we think that the evolving towards autonomous network OEM to troubleshoot the failures of the control protocol is very important. Okay, so that's here we wanted to export the information related with the control protocol. We think about the two possible options. The first one is that proposing a reuse existing BMP to propose some new BMP message for other control protocols. So this has some advantage. So that's maybe this is the less implementation, and so this is for the and also the actual deployment of the BMP. So based on the extension of the BMP for NMP, so it can be incrementally deployed. So this is the advantage. But the challenge is the BMP is at the beginning it has the specific scope, but now it's extended for other control protocol. I think this is also face the challenging. So this draft, firstly, we take the option 2. We propose a new network monitoring protocol. So it has a similar framework, but it's independent from the BMP. So this may be more flexible and customized for IDP and other control protocol.
10 minutes.
Okay. So this is not the intent of this presentation. Here is just quickly overview this is the design of this protocol for the ISS. So here we simply have the initiation message. We also have the status change message, and we also have the statistics report message, and also this is the PDU monitor message and the termination message. So this is the protocol design. So here we have this common header, and this is for the peer. So we have this agency header. This is for the ISS, and for some this is the initiation. For the report the capability, it has the TRV, and for the some this is the neighbor status change. It has some of the reason. Here is the reason TRV. As the statistics, so also has some of the statistics TRV for the statistics purpose. And last one, this is the termination info TRV for the termination message. Okay, in fact, we take the chance to this. In fact, once this work has been proposed in the IETF, we get a lot of comments in the mailing list. At that time, I is busy with many affairs, so that I cannot reply all the comments in time. So I take the chance to say thanks to AC, Randy, Jeff, and Robert Wilton, Robert team, and Greg for the valuable comments. So here, that's a summary of the comments like this one. So the first, they have this concern. Why not gRPC young? So this is the first. Second one is why not BGP link state? So we will refer to next slides to explain more. The third one, that is the history for reference. We also believe that forget history, to repeat it. But in fact, we are also part of the history. In the past years, we are involved in much work in the gRPC, netconf YANG, and even the BGP link state. But the experience triggered us for complementary solution combined with the existing work. We believe this may solve the network OEM issues better. And last one, so that is proposed Greg to refine this draft. So this will done in the future version. Okay, so here we explain this why not gRPC and YANG. So that's in fact, in the network telemetry framework, we list identify what's the control plane telemetry and what's the managed plane telemetry. From this, our definition, we think control plane telemetry is to monitor network running status, protocol packets, protocol statistics, and peer status. And here, this is why not gRPC for the control plane telemetry. So here we think there has a difference. So we list this difference from several aspects. The first is the data contents. This is the management telemetry is the device viewpoints. but the control plane telemetry is from the protocol viewpoints. The second one is the data interaction. So that's for the managed plane is the status data retrieve and configuration manipulation. But for the monitoring, it's not interactive. It's a unidirectional data retrieve. Time sensitivity, that is for the managed plane. So now that we tried to improve the performance, but from our point of view, it's still not very time sensitive. But for the troubleshooting, for the control plane, maybe more time sensitive. And this is similar for the data update sequencing. And this is the exports. I think this is the result, not the reason, I think. So. And for the data modeling, we think that's this one we use the young model. But for this one, we use the header plus the TRV. And the encoding, this is the channel, and this is the PDU. Yes. In fact, we tried to simulate the work of the NMP using gRPC and YANG. We think it's a little difficult because many troubleshooting work may be done based on the protocol packets. But if we use the YANG model to monitor these packets, so that we must define the YANG model. We firstly pass the protocol packets, and then we will define the YANG model for this packets, and based on this, export the data to the analytics station. The first pass the protocol packet may lose some information. So we think, and also the pass the packet, also the time consuming. So we think we directly to export the PDU is not necessary to pass it, directly send to the analytics station. So ask the station to pass the original protocol packets, so that maybe can analyze root cause for some failures of the control protocol.
Finish within 2 minutes.
Okay. So this last one, this is why not BGP link state. Firstly, we think the BGP link state is not for the purpose of the monitoring. Though the use cases may be done by the BGP link state, but we don't think BGP link state is the purpose for monitoring. We think the principle to decouple the operation protocol and the monitoring protocol is a basic principle. We don't want to monitoring protocol to solve the issue, but at last to cause the issue for the existing protocols. So that is the purpose. Okay, so this is the conclusion. This is we think that there exists a difference between the control plane telemetry and the management telemetry. But we also agree that margin may overlap. And also the use cases here propose to justify the necessity of the NMP. But this does not exclude the possibility of other methods. We think maybe combine these solutions together, maybe for a better solution. And for the past years, we learned from the SDN. We think at the beginning, they always debate what's the management, what's control. But we learn follows lessons. So that sometimes combine this management control plane, even more methods, analytics. So that's used for better solution. And this one, so this is maybe has a different choice because the different, based on the different requirement. This is the performance, cost, standardization, maturity, customer preference, etc. So we think the last, we believe the requirements of the customer and running code to justify the university finally. Okay, so I think this is the finish this presentation so that we close the existing comments and solicit more comments, and we will also detail analysis of the different message for the advantage. Okay. Okay, any comments?
We're going to need to take that back to the list because we got to move on.
Okay.
Thank you.
Okay, thank you.
The next one, Kasim.
Hello everyone, this is Xie Chongfeng of China Telecom. This is about coordinated address space management CASM architecture. CASM is a general reference architecture designed to as a basis for developing synchronized address management for multiple use cases. Actually, this draft has originated from several early documents. So this is output of multi-site. And with these models, we hope that the address pools in network can be configured automatically instead of manually. So the time can be, network management can be reduced. And hopefully, we also hope that this can improve address usage. In last meetings, the version 0 has been presented in IETF 101. So we received several comments. The current draft has been revised based on these comments. In some terminology have been changed, such as APMS appeared in the early version. And SPL draft reference were replaced with the latest ones. It is intended to handle this CASM intended to handle containers, VLAN assignments, etc. A number of enterprise operators has need for this type of solutions. We also made some other refinements, for example, correct some editorial errors. And in this draft, the component introduction is moved close to the reference architecture in section 3. So I want to mention here is that, also we want to mention here that actually we have implemented the prototype of CASM 2 years ago. And 4 vendors have joined this work, and we have carried out the field trial in our network. So in this draft, we have a new use case, which is raised by Italian Telecom, a service SD management. In order to build end-to-end service in private or public cloud, the SD orchestrator need to need to deal with addressing underlying network elements. So, for example, manage IPv4, IPv6 addresses, also MAC addresses to assign to network interfaces. I think that CASM can meet this kind of requirements. The typical use is that the application of the service provisioning of layer 3 VPN and layer 2 VPN by SD orchestration level. So during last meetings, we talk about the requirements from enterprise operators. So in this draft, we summarize some basic requirements from enterprise operators. The first one is that it needs to support automatic correlation of address block and single address simultaneously. And moreover, using a friendly interface will be needed to monitor and show address usage. And so technical detail of the low layer configuration and action can be cannot be exposed. And manual dynamic resource condition are both supported in CASM. Sometimes address allocation can synchronize with other entities, such as SD and such as DSL or Steam controllers. We received, as mentioned earlier, we received comments in the last meeting, and we also received other comments in the mail list. So here I only show some of them. The first one is that comments from Tianzhou. They gave us lots of comments, and since it has been discussed in many lists, so I will not illustrate them one by one. The second comments come from Matt of Orange, French Telecom. We give some feedback to clarify some of his concerns. We also received feedback from the Yulu of Google. He asked whether how to use this architecture into data center networks and enterprise networks. So I want to take this opportunity to give our thanks to all these people for their comments and contributions to Chasm. So next step we will continue to refine the document based on new comments, and any new contributions are welcome. And specifically, our efforts will be given to enterprises operators requirement scenario. So we also like to know whether this document can be adopted in this meeting as a working group document. Thank you.
How many people have read this document? Actually, quite a few. I'll raise my hand. I read it as well. While this won't be a formal request, we'll do that on the list. Do people generally who have read it or who haven't feel that this is worthy of adoption as a working group item? Less than those who have read it. Chris.
Can we ask questions?
Yeah, oh yeah. Okay.
I apologize for not reading the draft, but the slides basically make it sound like you're proposing. Sorry, my name is Chris Morrow. I work for Google. It sounds like you're proposing making a database with an API. I don't understand why that is A, generic, or B, a standards thing, or C, going to work for me and you at the same time. Like, as part of like deploying stuff, like you build a database that has a bunch of identifiers, maybe IP addresses or VLANs or MAC addresses or what have you, whatever it is that you need for your thing you're deploying, and you build a bunch of hooks into this stuff that does all the deployment work for you, the automation. I don't know that that's IETF work. It seems like that's stuff I do every day. That's all. Does that basically capture what you're proposing though?
This is Will from Huawei. So I guess it's more like a clarifying question, right? So actually, basically, this draft is mainly about this architecture and the interfaces between this centralized way of controlling and manipulating the addresses.
Yeah, but I guess I'm not seeing that those interfaces could really even be standardized, right? Like CA Unicenter does something totally different than IBM, whatever the heck it is, Tivoli, and different than Oracle's product or whatever. Like, they all do something different. Everything I built does stuff that uses my internal infrastructure. Like, I imagine that's what happens everywhere because that's what happens everywhere I've seen. What does DT use? Some internal phrasing that you built? Yes. Yeah, it's okay. I guess it just shocks me, or it just struck me that like this isn't really it's not identifying something really.
I guess there is some slightly different understanding between yours and what Chongfeng is proposing. Actually, from their deployment, they have 4 vendors. Connecting to their centralized controller, and that's why they need this standardized.
Would you like a gRPC? Would you like a protocol? There's again, like he's building some bespoke crazy business. Like, that's great. So did Rudiger. So did Dean. So did Dickens.
Ignas Bogdanas. This topic has been discussed for quite a while, and I remember there was something like a semi-BOF or an official meeting, probably a couple of IETF cycles ago. And at the time, there was one interesting topic raised by the registrars to try to define an interface where a potential user of a block can request a block from a registrar. And I'm not talking about the level of a registrar, but as a address block leasing or acquiring mechanism. And that seems to be of a possible value, at least looking at the developments in the industry. Trying to standardize the internal implementation of how do I allocate and assign and distribute addresses, identifiers, whatnot, it's an implementation domain. IETF doesn't seem to be the right place to standardize some either vendors or some internal implementation for that. Even besides being not the right place, that's just not possible because each and every user, the identifier and address allocator mechanisms are so different and so specific to the environment in which you use that it's hard to talk about standardizing something. Otherwise, well, and therefore I would suggest probably that you should explore the space of interacting with the address registrars more. That was one of the topics discussed in that your interim, and it doesn't appear to be on this presentation here. That seems to be the real problem. What you are describing here, yes, it's a problem, it's a painful problem, but that's an internal problem. And I do have a solution for that myself, and that solution is very different to Chris's. And if we try to do a mechanism which tries to standardize that, it will be both painful for both of us, and it will lead nowhere. This is a feedback from with the operators at home.
My question is, I want to know the plan to deliver the custom-related draft. Is this the only draft you want to standardize? Also, because usually the framework draft is a kind of support document. It's not necessarily being standardized. If your goal is to standardize the interface, so you may want to deliver a YAML model, maybe you can just incorporate this framework into that specific document. And you also attend the L2SM, right? And also L3SM. I think both of them include everything within one document. What's your opinion?
We plan to submit the YAML document after this meeting.
So your final goal is to standardize the interface, right?
Actually, this document is in our plan. This document is also our one output work, and we also plan to submit a YAML document.
My suggestion is you can firstly submit those the YAML model.
The YAML first.
Yeah, first, and we see if we really need to adopt this framework, this architecture document, or
Okay.
we work on the YAML model directly.
Okay.
Other comments? Perfect.
Next, the SD-WAN service model.
Okay. This is about young models for SD-WAN VPN services. As we all know that SD-WAN VPN service is very popular. It is provided by operators to enterprise users with Azure and assuring IP quality service, and it's an annual network to the enterprise users. So these models give an abstract with the configuration parameters, and it is up to the management system to take this as an input and use their specific configuration parameters. Overview of SD-WAN. It is a kind of new VPN service provided by using internet connections only or together with traditional transport techniques, such as MPS or VPN. And it also orchestrating a function instance such as vFile or VCE on customer premise or cloud. So one of the major features of the SD-WAN is that it needs rapid deployment, fast provisioning, for example, within hours to meet user requirements. We think that SD-WAN is different from L2 VPN and L3 VPNs. The difference are L2 VPN and L3 VPNs are provide provisioned and P-based VPN, and the P equipment maintains the VPN state for each VPN. On the contrary, SD-WAN is a SE-based overlay VPNs, and the P has knowledge of it. But there's the relationship between them is that SD-WAN can leverage L2 VPN and L3 VPN as underlay transport technologies. Why a service model needed for SD-WAN? Service agilities of SD-WAN means that service is quite dynamic. For example, we need to add sometimes add new branches, adjust bandwidth. Sometimes it may change over time in holidays. And we also need to increase the cloud service functions, and of course, we need a service lifecycle management. So all the kind of features requires orchestration and automation. So the service customer requirement should be abstracted. We need to define SD-WAN service model in the NOS interface of the orchestrator, and the specific detail of the protocol and network equipment configuration cannot be exposed here. So here's about SD-WAN service model. Same to L3SM, L2SM. SD-WAN service model adopted a tree model architectures, and it has two major components. The first one is segment network that for given enterprise SD-WAN, and it has multiple virtual network which may be separately. And then the second one is policy. Policy could be applied to per segment or per set application of flow granularities. So in these models, the first parameter is size. Size means that customer office located at specific locations. It may have the following attributes. For example, the equipment types, the transport links such as access types, IP addressing, and the protocols. The second one is segment network, which has been mentioned, which will be discussed later. And the third one is policy. Policy may include the path selection policy, quality of service policy, and the security policy. So about the segment network. Segment network means virtual network in given SD-WAN networks. The intention of a segment networks to separate the traffic in set-to-set communication or set-to-external network communications. So the parameters of segment network include the topology. So the proposed service model here support hub and spoke any-to-any topology. And here also set list. And the set list is a non-network list, which means that a set of non-network that attach to this segment from different locations, but belong to the same segment network. The parameters of network list include L2 attributes, IP addressing, and protocols. So about the policy, as I talked earlier, there's several policies. Also here, we're going to talk about the path selection policy. There are three parameters in this policy. The first one is application of flow classification. And the second one is application of flow SOE. The third one is primary path or secondary path. So for given traffic, we will classify the traffic based on the first parameters. We'll classify the different services such as voice, video, game, and some critical data. And we also need to measure the SLE of this path. We'll monitor the delay, jitter, or packet of the application of flows. Then the path will be selected based on this status, send the traffic to appropriate transport network link. So this is the first time to deliver this presentation, and we are looking forward to receiving more comments and suggestions to this draft, and we'll continue to revise it in the future. Thank you.
Hello, Adrian Farrell. Thank you for this. Interesting. I'm obviously familiar with L2SM and L3SM models. What I'm trying to understand with this one is who are the users? So somebody builds the model and sends it to somebody else who consumes it. In the L2SM and L3SM cases, it's the customer talking to the provider.
Mm-hmm.
Because this is a CE service, not a PE service, are you making some assumption like the CE is actually controlled by the operator?
Yes, I wish to answer your question. Although this SD-WAN is a C-based VPN, but it will be operated by operators or some other SD-WAN service providers. So this model can also be used between customer and the operators. The difference is that the configuration will be based on C, not on P. That's the difference. Okay.
Romeo from Huawei. Regarding this work, I think the SD-WAN is a very popular use cases of the SDN. I think that's it has some difference with the existing L2SM, L3SM. So I think they try to define the service model for the SD-WAN is useful. But I have this one. I'm not sure because I know that RTG WD has a work for the SD-WAN. And also, I'm not sure that's because it's put this work in the OPSAWG working group because it's not found interface, or it should be moved to the RTGW working group. So I'm not sure. Maybe.
Thank you for providing this information. I will check this. Okay. We can talk this offline meeting. Okay. I cannot answer your question right now because I don't know.
Yeah, but I think maybe the question is for the chairs and ADs.
Okay.
Right, that you ask. So one of the reasons why SD-WAN as a topic is appearing here is that there is an unofficial interworking with the ONUC Open Network Users Group. And they try to coordinate the development of SD-WAN from a usage point of view, from a user perspective. And they open the knowledge that they don't have enough of expertise for the modeling on the young side and how the actual technology components work. Therefore, the work split probably will look like that. They bring in the requirements, what is needed, and the actual technical development work is happening here. That's the reason why this work is showing up here. Where the home for that should be, which working group, it's an open question. It's an experimentation, most probably in routing. Most probably in routing, as that is much closer to the routing domain. However, from the usability point of view, those models, they are far closer to the service models in the terminology of IETF. So I cannot give you a definitive answer where it should belong. I think it should be iterative, do some experimentation, spin a few revisions, see how that fits, interwork with owner, and maybe that can be published as an AD-sponsored document without any formal home. It's still too early to say at this point of time. If there's no more comments, I think it's the end of the OPSAWG meeting, and we will start the Ops area section.
The blue sheets are still going around. Someone, what are the, where are the blue sheets? Okay, we got some behind you. Whatever. There should be one other clipboard, maybe back there somewhere. We'll look for it. I will continue to write up an Etherpad, though I would appreciate other help. We have another blue sheet. Anyone else need the blue sheet? Okay. And over to you.
Thank you. Just double checking, you said you'd carry on doing minutes, right? Wow, on your phone? Yeah. Good Lord. So hello everybody, I'm Warren Kamari, and this over here is Ignis, and I am looking at the wrong laptop. Let me check if we have slides set up. So, this will take a few seconds while we get our slides organized. Oh, excellent. So this is our administrivia slides. Once again, the note well. Hopefully you have already noted this well when it started off with OPSAWG. Please make sure that you look at this and understand it. It says all sorts of important things, which I'm not going to try and interpret for you. You should discuss this with your lawyers / rabbi / whatever. Welcome to Ops area. We've already done this bit. I'm Warren. This is Ignis. We've done the note well, blue sheets. Please make sure you have already signed the blue sheets. Otherwise, next time we get a small little room. We have a Jabber scribe, I believe. Who was scribing? Scudder. Thank you, Scudder. And Joe Clark is doing minutes. Thank you, Joe. And here are where the meeting slides are. So we are currently doing the administrivia bit. And we're going to swap the order of the next bit around so that Ross Callan will go next, and then after that it will be Ignis. I don't think anybody will care, but does anybody object or have any agenda bashing? Didn't think so. So let me just get the slides queued up. In the meantime, our first talk will be from Ross Callan, who came up to present on this in the routing area working group. And we asked him nicely if he would mind coming along and presenting this as well here, because we believe that it will be interesting to people. And thank you, Mr. Ross. Which is the clicker? Do you have the clicker?
You can use the clicker. I was not that good at clicking last time.
Okay.
So my name's Ross Callan. I used to attend the IETF, and then 2 years ago I retired. And when I retired, I sort of had this hobby over most of my working life of sort of keeping track of ways that entire networks can sort of run into trouble and crash or fall over all at once. And after I retired, I thought, I really, I'll have lots of time. I'm being retired. I can write this all up, because it seemed to me it should get written up because we don't want to do it again. And I like being retired too much, and so I never got it done. And then you guys decided to have an IETF pretty close to, where I originally came from, and even where I was currently living, or where I am currently living. So I thought, well, maybe I'll at least come by and present it to you guys so that you can, I've written down that. So I suggested to the routing area directors and the ops and management area directors that I give the talk, and they immediately said yes, which meant, oh dear, I was going to actually have to do the slides. So I did the slides, sent them in, and here I am. Next slide. So there have been some interesting events in the 1970s, 80s, 90s, and I think that one of the events I'm going to talk about even occurred after 2000. We didn't always know what we were doing way back when we started building this thing called the internet. Some of the knowledge of things we did wrong is in the minds of old people, and some of us old people retired 2 years ago, and some of us haven't quite retired yet, but will, at some point in the near future. We're not going to be here forever, so I thought it'd be a good idea to write it down. So I got a bunch of examples written down here. One thing I want to say is I made an effort in these slides to try to be vendor neutral for several reasons. There's no point in pointing fingers. In many cases, the stuff that got deployed specifically because it was the best stuff that was available. So basically, the equipment that did not collapse like this was even worse. That's a reason to not point fingers. There's just nothing to be gained by it. I have not mentioned anything about proprietary protocols, partly for that reason, that you can't really say, this proprietary protocol had this problem and then not point any fingers as to why. So let's go to the next slide, and we'll talk about one of the earlier problems. Way back in the 1970s, the ARPANET was routing on a distance vector routing protocol that ran into some of the troubles that distance vector protocols used to run into. So they came up in the late 1970s with something called the new ARPANET routing protocol. Back then, the ARPANET was running at much lower bandwidths than we have today. I think that the main wide area links were 56 kilobits per second. Given that much bandwidth available in the core main backbone links, you want to be a little careful about your use of bandwidth for control protocols. So the sequence number space on the new ARPANET routing protocol, again, is link state routing protocol, so you have these maps of one node's view of its local topology would get flooded around. That was flooded around using a sequence number that was 3 bits. Given a 3-bit sequence number, that means you only have 8 possible values, which means you're going to run off the end and have to go back again. So it was a circular space. And so, whether A was before B or A was after B could be figured out by seeing which way was closer around your circular space. Way back then, a switch happened to crash. When it came back up again, somehow whoever implemented that switch thought it would be great fun to forward all the packets that were in the queue because maybe some of them would still be useful. So it did. Well, it turns out one of the packets in the queue when one particular switch came back up again was an old routing update that happened to be exactly halfway around the circular sequence space from an update that was in process at the time. So there were therefore, that one old update, the one that was only slightly old, and the brand new update, all 3 of those were all going around at the same time. And they just so happened to be, so their sequence numbers A, B, and C came out as A is greater than B, and B is greater than C, and C is greater than A. So update A replaced update B, and update B replaced C, and C replaced A, and the 3 updates chased each other around the ARPANET as fast as switches could forward them. Next slide. Oh, you got the next slide already. Oh. So 3 updates chased each other around the ARPANET for a few hours. Fortunately, back in those days, the telephone network did not run over the internet. So it was possible to pick up a telephone and call somebody and say, unplug your switch, packet switch, please. So somebody was able to physically go to each packet switch and unplug it. And so they were able to turn off all of the packet switches except two. Well, once they got it down to only two packet switches were still up, there was therefore only two views as to what was the most up-to-date routing update, and with only two, you can't chase each other anymore because one comes out ahead of the other, and so then there was only one, and then you could plug all of your switches back in again. As you might imagine, if this were to happen today with 100 or maybe even 1,000 routers in your network, it might be quite unpleasant. It would be even more unpleasant if your phone system went over the same network, because how would you call people and say, go unplug your switch? Next. Oh, he's faster than me. In the early, I thought it was the early 1990s, it was like very early 1990s, there was a network out there with a stable network that was working well with a small number of the biggest routers that could be bought at the time, and a large number of little routers that were all single-homed to the core. And the service provider thought, I really care about reliability. I don't feel good about all these single-homed stubs. Let's double home them. And added a second link for all those stub networks. And of course, the result was their entire network immediately collapsed. What happened? A router, in this case, the router at the top in the middle, had a link state advertisement to send out, sent it to all its neighbors. All its neighbors thought, oh, all my other neighbors will want to hear that too, and forwarded on. A whole bunch of LSAs, identical ones, all showed up at the same place at the same time, and it was too many identical updates arriving in one place at one time, and the router couldn't handle it. So it just sort of keeled over instead. So one of the lessons is that buffering and discarding duplicate link state advertisements is actually a hard part of OSPF and ISIS. We did not predict that. I remember at the time people complaining, oh, the Dijkstra is so slow. And then somebody looked at it in detail, no, the Dijkstra wasn't slow at all. I couldn't even imagine at the time how Dijkstra could be that slow, but it turned out it was dealing with redundant link state advertisements, noticing they're redundant and throwing them away was slow. A similar issue happens with IP over ATM. Some of the, there was a time in the past when ATM switches and frame relay switches were faster than routers, and so people would build networks with ATM switches and then attach their routers over it with a full mesh, and that meant that every router had every other router in the network as its immediate neighbor. That was a little inefficient also with OSPF and ISIS, so we added mesh groups to handle that. Now, this one I know was 1992 because I remember where I was and what was happening at the time, which I won't talk about. But somebody decided, a network operator decided to grab me and pull me into the lab and say, look what's happening. So after some analysis, it turned out what was happening is that a network was sitting there stable, working fine for quite a while. And then it just so happened that several things happened in a very short period of time. This caused several different routers to send out link state updates at the same time, which caused some other routers in the same network to get busy. Now back then, or in 1992, processors were slower than they are today, and they spent most of their time forwarding traffic and only spent a bit of their time dealing with routing updates. And so if they started spending a lot of their time processing link state advertisements, they fell behind in some cases in their processing of the hello packets. And so if you fell behind in the processing of the hello packets, a timer would go off saying, you haven't got a hello packet from this neighbor for a while, he must be down. Well, in fact, you had the updates, the hello packets, they were just sitting in a queue and you hadn't gotten to looking at them yet. But once the timer goes off, you decide, okay, he's gone, I'll send out another link state advertisement saying that neighbor's gone. So a few routers got slow. decided to send out these updates that their links were down. That meant that there was more work for more of all the other routers to do. They all started doing too much work on processing the link state updates, and all noticed that they hadn't gotten hellos, and so they all disconnected all of their links. Every link in the network disconnected. Now the routers had nothing to do, so they caught up. And since they caught up, they brought up all their links with their neighbors, sent out the link state advertisements, everything came up and worked fine, except for another problem. All the links had come up at the same time, and they had fixed timers in terms of when they would re-advertise their link state packets. So 20 minutes later, everybody sends out an update at the same time because it's 20 minutes past when it came up. Well, that means everybody gets congested. Nobody processes hellos, all the links go down. Then they all come back up again because nobody has anything to do, and 20 minutes later, all happens again. So, at some point in 1992, somebody actually grabbed me and pulled me down in the lab and forced me to sit and watch for an hour as everything went down every 20 minutes, and then it all came back up again, and then we could just chat and nothing was happening. And then 20 minutes later, we'd look as everything went down. It was great fun. So that's what I did in 1992. It only took me an hour. Next. So the solution, you optimize your protocol processing, you prioritize the hellos, you do the hellos first before you do anything else, and you randomize the timers, so if a bunch of stuff happens at once, it doesn't happen all at once again sometime later. This was allegedly known in 1992 and 1993 when I saw a bunch of people working on it, but a couple of years later, we got to the next slide. An ATM switch network, which happened to be using OSPF as its routing protocol, belonging to a rather large service provider that you've all heard of, but we will not name, happened to have 2 or 3 links went down, which caused the network to partition. And it was, a big piece and a small piece, but, it stayed down for long enough for all of the link state advertisements on both sides to get refreshed. So at some point, one of those links that caused the partition came back up. Probably a human went out and, replugged something in that somebody knocked out or whatever and caused the problem. As soon as that link came back up, the ATM switch on each side of that partition, they try to do database sync, right? So each switch sends everything it knows to the other switch. And then of course the switch that receives all that sends it to all their neighbors and they flood it through their side of the partition. That apparently even the small side of the partition had enough link state advertisements that having them all arrive at once caused all the routers on the other side to become too busy. And so they dropped their hellos, so they dropped the network. So sometime in the mid-1990s, an entire large service provider somewhere in the US all went down and came back up again. Now, to the credit of the software engineer who had written this software, they did randomize their timers. So when it came back up again, 20 minutes later, when it was time to send out all your link state advertisements again, that was spread out enough that it did not cause it all to happen again. This is supposed to be a build, but it's not a very exciting build, so it's fine having it all as one slide. You're all familiar with denial of service attacks. Some nasty person somewhere takes control over a bunch of hosts around the network and they all send packets at the same place at once. I'm pretty sure it was January 2003 where the slammer worm hit. I assume that anybody who was managing a network in January 2003 can confirm whether that date's right or not. Although I think I Googled it and verified it was right. Very rapidly propagating worm that doubles every 8 seconds. So, from the time you notice it until it's a disaster is not very long. Slammer worm propagated by picking an IP address at random and trying to attack it. And if it could get in, it could. And if not, it would pick another one at random and try to attack it. So some of those randomly chosen IP addresses just happened to be the IP address of a router. So there was lots of traffic aimed at the router as well as a lot of traffic aimed at everything else. So the router's processors were busy, the links were busy, everything was busy, And again, even as recently as 2003, a lot of the routers dropped their hellos, dropped their links. I've heard of some cases of operators finding they could not sit at the console and manage the router because the router wouldn't listen to their commands they were typing on the console because it was too busy dealing with all the packets that were arriving at it. So in some cases, they had to physically disconnect the ports, go to the console, type in the network management command to be the packet filter to dump all of the attack packets, and then go and physically reconnect the port. And then, of course, the router would do nothing but drop attack packets until enough other routers are doing the same thing to knock the attack down. From what I heard, it is not clear whether or not this was CPU congestion or link congestion. But I think both were going on at the time. Again, prioritize the hellos, give priority to the hellos, and then next to the routing packets and the network management packets. And only after that do you bother with actual traffic. This is a fun problem that happened also sometime in the 1980s. ISIS and OSPF were defined in the mid-1980s. So it was a time when processors were somewhat slower than now, and they were forwarding packets. So the original specs were trying to minimize the strain on the CPU and trying to optimize the flooding. So the ISIS spec, in order to get the flooding fast when you have slow CPUs, looks at the outer wrapper first. It looks at the checksum. Is the checksum okay? Yes. Okay, next. Look at the link state packet number and the sequence number. Is this a new packet? If it's good, it's a new packet, send it to all my neighbors first, and then look at the insides. At the time, ISIS and OSPF were relatively widely deployed. ISIS had been solid for several years, and most of the biggest service providers in the world had ISIS running for at least a couple of years and working well when a problem occurred. As networks got faster, right, more packets. Somewhere on some router, somewhere in a network, which won't be named, there was an interface that was just trashing packets. It was just changing bits. If you change one bit, the checksum will always catch it. If you change a bunch of bits, some packets will get through, and it's about 1 in 65,000 that will get through. So you change one bit, you change several bits randomly in several updates, and after you've randomly trashed 65,000 or so updates, something's going to get through. Well, some of those may have trashed bits that cause the sequence number to be wrong and it gets thrown out or whatever. But one got through which checked the sequence number and got past the checksum and got past everything. The outer wrapper was fine. The packet got forwarded, flooded out, and then the router looked at the inside, found a length field out of range, and crashed. And the fun thing about this, a couple of fun things. One is you first forward the packet, then you look at it and crash. So all your neighbors get to crash too. And another fun thing is this one hit more than one vendor. And so you managed to take down multiple vendors in one network all at once, which is great fun. This is a different problem. Now, the distance vector count to infinity, I think probably you guys know this well enough. I could have done 15 slides on it, and you're probably glad that I only had 2. I think the problem's pretty well understood. You have a destination A. The router next to it says, I can get to A, it's only 1 hop away. The next router hears that, says, oh, I can get to A, it's 2 hops away. The routers next to that say, I can get to A, it's 3 hops away. However, just when they say this and when they notice it is going to be a little bit random as to the timing of events. So if A were to go away at some point, that guy in the middle might say, I can't get to A, it's not 2 hops anymore, I can't get there. And those 2 routers over on the right might notice that at different times. So one of them might immediately notice, oh, he said he can't get there, but this other neighbor said he can get there, it's 3 hops away. So I'll tell them I can get there, and it's 4 hops away, right? And depending on the order, in one direction or the other, you can start counting to infinity around that loop. And so, I just assumed one particular order in which things were noticed. So the router on the upper right says I can get there, it's 3 hops. The guy at the bottom hears that, says it's 4 hops. The guy in the middle says, okay, I can get there, it's 5 hops. The guy way over on the right says I can get there, it's 6 hops. And you count to infinity. Well, RIP handles this by setting infinity to a small number. Right? 15 is infinity, so you don't have to count forever. You only have to count to 15. It's a little bit ugly. A bunch of fixes have been proposed, and some have been deployed. There was an interesting augmentation of this problem. In case this problem wasn't bad enough, we found a way to make it worse in the very, very early NSFNet. And that relates to delay-based routing. In addition to having fun with counting to infinity, we've also had fun with delay-based routing, where some routing has been done in the past where we use like real-time queuing delays, including the queue. And again, back when networks were slow, the queuing delay could be bigger than the propagation delay, so it could be what really mattered. In the early, very, very early NSFNet, they used a bunch of, a friendly university professor and some students of his put together these things called fuzzball routers, which used a delay-based routing in the core of the NSFNet between these fuzzballs. So they looked at the real-time queuing delays. And then on the outside of the NSFNet, routing was done with RIP. And they mapped one to the other. So if from one edge you got a destination that was, let's say, 3 hops away, that 3 hops would be mapped to a particular delay and advertised into the core. That delay would get added to the delay of whatever the queues were in the NSFNet. Somewhere on another side of the NSFNet, they would have gotten to a slightly higher delay. They would map that back into a RIP hop count and advertise it out on the other side. Now, one fun thing here is with delay-based routing, where you have multiple ways to get across the US, let's say, you have one path that's got very little traffic. The delays are very small. It gets advertised with very low metrics. Another path is more congested, so it's got high metrics. All of the traffic goes on the path that's advertising low metrics, so that gets congested. The metrics go way up. It's re-advertised a few seconds later at a much higher value. The other path has gotten empty in the meanwhile, so everything goes back the other way. So with the delay-based routing, you tend to get this flapping back and forth. You put that at the core of your NSFNet, and you put RIP on the outside with the counting to infinity, and you're feeding rapidly changing up and down metrics into RIP on the edge. As you might imagine, this did not actually work very well. I remember being logged in at the National Center for Atmospheric Research, which was just hosting a meeting. It had nothing to do with any of these problems. And I was logged into my computer in Cambridge, Massachusetts, my home computer. And it just froze, and it just sat there for 45 minutes. I couldn't do anything. I couldn't log out. And then 45 minutes later, it came back, and I was logged in. If I had walked away, any student could have walked by, sat down, and started typing away on my computer in Cambridge, Massachusetts. And of course, the first thing I typed, obviously, was log out, because I had to, it was going to hang again, and I didn't want to wait another hour before I could log out. So we had problems way back when. That got fixed by changing the routing quite dramatically in the NSFNet. We also had an issue that occurred in the mid-1980s. The ARPANET, having noticed some of this problem with delay-based routing, moved to a metric which was a linear combination of hop count and delay, with the contribution of delay being small enough that you were really just changing within one, right? So you do minimum hop, but with a tie, you take the less delayed route. The problem is that with 56 kilobit lengths, which might have gone a little bit faster by then, but with traffic demands going up, after a while, the delay got large enough with the linear combination of the two. What used to be an overdamped system became an underdamped system. And so they went from nice stable routing to, again, wild oscillations because of this problem with the damping not staying sufficient. Now it's time for John Scudder to get up here. Now, the last time we went through these slides, they were a little wedged, and so John had to talk to slightly convoluted slides, but that's the fault of a translation between different slide formats.
I get to hold the clicker. Okay, so I guess this is a good thing. Didn't manage to come up with as many halt and catch fire problems as Ross did. So that's probably good that BGP doesn't have that many documented examples of the whole thing falling over, especially because we run it across the whole world. But there are a bunch of things that I did manage to come up with that are all kind of in the category of, or at least most of them are in the category of times when somebody showed me something in the protocol that made me sort of sit down, scratch my head for a while, think about it for a minute and say, oh. So the first one is this thing called BGP wedges, which I think is wonderfully named. And I think due to Tim Griffin. I mean, I know that he's the one who showed it to me. I'm not sure if he came up with the name. And basically it illustrates that you can take a really simple protocol and apply a really simple set of rules to it and think for years that you understand it, and then realize that no, you don't understand the emergent behavior at all. And in this particular case, what I didn't understand at all until somebody pointed out to me is that BGP isn't exactly, well, it's deterministic, but it doesn't have a single predictable topology that you can come to. This is a very simple example. If you find this fun, you should read the RFC. There are a bunch of much more pathological examples. Cool. This is supposed to be a build, and it's supposed to be helpful, but instead it's just line salad. I'm sorry. But I have a laser. So what we're looking at here is a customer who has a link here. Maybe it's low bandwidth, or maybe they pay a lot for traffic they receive on this link or something. So they only ever want to use that for backup. They want to get all their traffic over this link normally. So when the topology comes up, everything is good. Traffic forwards. Oh, and the way they accomplish this is they send a community to this provider. The community has the local semantics of please use this route that I'm advertising you along this link as a route of last resort. If you have any other option to reach this prefix, please use that instead. So they advertise that community. The provider also gets the route this way and selects that route, and so everything is good. The forwarding topology goes this way, up and around, as desired. Great. Now we fail this link. What happens? Well, that's fine. We have this route over here. It gets, let's see, so this link goes away. That route gets withdrawn, and therefore this route gets advertised off that way, and in a short period of time, you're back in business forwarding traffic via your backup link just the way you want it. Great. Now is the fun part, where things get wedged. This link gets put back in service. So we just go back to this forwarding topology, right? No, we don't. What actually happens is, because remember we've now got routes that got advertised this way, and because BGP has the property that you only advertise your best path, if this guy here, this provider Y, happens to prefer the route that goes through provider X, which we're imagining he does in this case. He just happily continues to use that route. And so now the forwarding topology looks like this traffic goes that way, this traffic goes that way, because provider X never receives a backup path, provider X never stops using this path, and the topology has now stabilized into a new stable topology that does something completely different from what the customer wanted. So, multi-stable. But sorry, BGP isn't even always multi-stable. Sometimes it's just not stable at all. So BGP MED oscillation has been around a really long time. That is a useful reference for it if you somehow haven't heard of this thing. And because it's been around so long, we have a solution for it, right? Wrong. And so how did this come to happen? It wasn't because the protocol designers, well, let me backtrack. The fact that it hasn't been fixed, I think, is a hint that there are two important things that are both important to users of the protocol that are not commensurable. You can't satisfy both the requirement to have a multi-exit discriminator, which, in case somebody doesn't know, is an attribute that lets you say, for traffic towards AS foo, prefer this link over that link. You can't have that and have data hiding, which you get from route reflection, and have them both work. And that's because the BGP route selection process assumes total ordering. The MED only gives you partial ordering. Those two things are fine as long as everybody tells everybody everything. So you're doing all of your, everybody's running the algorithm over the same set of data. That was true when MED was invented. Route reflection got invented later. Route reflection made sense too, except nobody noticed this little bit of subtlety. But the thing that's even more interesting to me is, even if it had been noticed at the time, I'm not at all sure that anything would have gone differently, because when it subsequently was noticed, the working group, carefully considered the facts and decided to do nothing, because throwing out route reflection was considered unacceptable, throwing out MED was considered unacceptable, so here we are. Everybody was just told to be careful and not run with scissors. Right, so this is the closest I could come to the actual halt and catch fire case. And there are actually some parallels between this and the case Ross was talking about, where you flood and then check the validity of the data that you've already flooded. So we in BGP, we have these things called optional transitive attributes. They're great, they make the protocol extensible, but they also mean that what can happen is you can inject a route into the BGP topology somewhere. It gets transited by a whole bunch of routes or routers that have no idea what the data is inside of it. So they just say, oh, this is an optional transitive attribute. I have no idea, but I'm supposed to forward it, so I do. This goes through, something that looks like a replication tree across the internet. Hits an AS that is full of routers that do understand the attribute. They all look at it and they say, this attribute is terrible. It's completely malformed. My peer must be insane. I'm resetting the session right now. Well, that was, good intentions are terrible things. Because the protocol designers have a good intention that if your peer is insane, because BGP is a purely incremental protocol, it's really hard it's impossible, in fact, to recover properly from desynchronization. The only safe thing you can do is reset the session and start from scratch. But of course, that doesn't make sense if the person who injected the bad data is somewhere way off across the internet. Pretty much the only good news about this is that we eventually realized that was a terrible idea and fixed it, but there is a lesson. I think this is my last slide. I tried to take these three things and sum them up into, like, what can we learn from these things? Some of these are sort of truisms, like you can take simple building blocks and produce really surprisingly complex emergent behaviors. Extensible protocols, BGP is famously extensible, and it's also, really, really simple. But the fact that it's so extensible means that we get lots of little extensions coming from different places. People don't consider how they will interact, and when they interact, sometimes they do so in ways that nobody, even the most expert people, would have guessed. Sometimes, as in the case of MED and route reflection, it's actually not possible to produce a solution within the context of the protocol that you've got that is both acceptable and correct. And this is the case that where we have the parallel in ISIS. Having data that is sometimes opaque and sometimes not is sometimes really terrible. So the word "sometimes" in protocol design should maybe sometimes be considered a red flag and reconsidered whenever you find yourself using it. And finally, I just really like the short paper on worse is better that you can find by Googling it. And I think that basically what I take away from that paper is that instead of doing something that is right and perfect, you're likely to win by doing something that's sort of broken but works most of the time. But then the problem with that is that it ends up being adopted by the whole entire world, and you have to spend the rest of your life fixing it.
I can do it.
So I just have 2 slides left, if we can succeed in getting them up. Okay, there are other examples that I have not bothered to write up. As I'm sure some people in this room know, there have been cases of operator errors. Distribution of full BGP routes into the IGP has not come across very well sometimes in the past. We sort of already mentioned that ISIS and OSPF are real-time systems. If you do the right thing way too slowly, you have a problem. And if you put 300,000 or more BGP routes into ISIS or OSPF, you might end up doing the right thing too slowly. There have been some hard-coded scaling limits, as well as other forms of scaling limits. There is some data on the internet about a signaling system 7 failure that was quite catastrophic that happened a while back. I'm curious as to what sort of similarities there are between that failure and some of the failures we've seen. I've heard vague rumors that most of us have noticed that it's possible for an entire network to fail at once, and sometimes we don't necessarily want to talk about it publicly. So whether there's other ways that things have failed that I didn't talk about, I think it's likely. And I did not mention the word multicast. Yes, one of the multicast experts who was there at the routing area open meeting gave me a big smile when I mentioned that. One multicast expert years ago pointed out to me that in things like Ethernet multicast, they were rather careful that in failure cases they disconnected rather than being overly connected. And one issue there is that in unicast, either a packet loops or a packet is delivered, but never both. Whereas in multicast, it is, at least in principle, possible to actually deliver some copies of a packet while another copy of the packet is looping back prior to the split to where you were delivering it in the first place. So you could get lots and lots of packets being delivered to one place, or the same packet being delivered many times, at least in principle. So they were very careful in some of the multicast protocols in the past to be careful to not cause that to happen. I believe they're, talking about multicast in general is really outside of the scope of this talk. So then my last slide, which is what do we do with this information? When I retired 2 years ago, I went to the IETF in Berlin 2 years ago and figured I was going to retire 2 weeks later, and did retire 2 weeks later, and thought it would be great fun since I was retired and would have lots of time to write it all up. But I've gotten absolutely nothing done whatsoever in 2 years relating to writing this up. And so when I discovered that you guys were going to meet in pretty close to my neck of the woods, I figured I'd show up and at least give this talk, which would at least force me to put these slides together, and and bug John to do the BGP slides, and at least I get that much done. There's this old saying that those who cannot remember the past are condemned to repeat it. The internet claims that that's caused by George Santayana, whoever that was. I have no idea if that's true or not, but obviously you can always trust everything you see on the internet, so it must be true. Back in the 70s and 80s, where some of these disasters occurred, it was sort of okay to take down an entire major service provider. Some of these failures occurred in places that were a little bit embarrassing even back then. If we were to take out a large chunk of the internet today, it would be very bad, and it would get, be the lead news on all of the news media, if you could even get a copy of the news media, and if those weren't down too. So we do not want to do this again. Personally, I think it would be wonderful if somebody were to want to write this all up, and I think I'm not likely to get around to it, so hopefully at least this presentation is helpful. And thank you.
So thank you. I think we've probably all got war stories that we can do. I don't think we have time for them, but seeing as I've got the mic, I'll do my one. So back in 2002-ish or so, I was working at AOL, and for various stupid reasons, we had one OSPF area with a couple of hundred routers in it. Seemed like a reasonable idea at the time, I guess. Anyway, these were all by one vendor, who is now defunct for various reasons. But an implementation bug was every now and then they would have pointer arithmetic errors. And the pointer to the OSPF database would be offset by 1. Suddenly you would end up with link state IDs of 255, 255, 2550, and a mask of 192.168.0.0. At which time this looks new, and it decides to flood this entire new malformed OSPF database to everyone else, who gets it, distributes it, and promptly falls over because A, they don't know what to do with it, and B, they've now run out of RAM. But yeah, it was very similar to the ISIS, let's forward this before checking game. And how much time do we have left?
We have time for questions.
This is
an important discussion, so we're thinking there's value in having this.
Robin from Huawei. Can you hear me? Okay. Okay. So I think, sorry, I missed the presentation in the routine area open meeting, but lucky for me to hear this in the OPSAWG. Okay, I think this work is truly should be appreciated. I think it's very, very useful. Yeah, but I think that's maybe I think this the RC will take a long time, or this one, or this not suitable. Maybe also some of the blog will be helpful. That because that's the quick, and also that's what, and also would like maybe a little abstract here because that maybe need more the figure, so that after the figure to explain this the issues maybe better for understanding. So maybe others can help to that based on the blog maybe help to read.
Yeah, with some of these examples, of course, I could have done, I could have talked twice as long, but also some of these examples, there's other people, many of whom also have old gray beards or at least gray hair, that would have more detailed knowledge of them. I think that most of the people who be aware of these examples are either active in the routing area or they're active in the ops and management, which is why I thought these were the right two places to give the talk. But of course, there's also some people who are familiar with some of these who retired. And in some cases, I know how to find them. In some cases, maybe, I don't know if John knows how to find Yakov or not. Yakov seems, I did actually succeed in calling him at home a couple of years ago because I had a reason, but it's, there's some people that are retired but can still be found. And so, yeah, I do think it'd be interesting for somebody to make, the effort to collect this information and write it in more detail. I also suspect, I'm hoping that if we could get a document that had some of this documented, there might be people who would not want to admit that they'd had a problem, but might be willing to admit, well, I've heard of a problem that looked like this that's worth, including also.
Understand. Okay. So I think that it will be helpful, maybe work out some of this cooperative way to that is inherit the knowledge. I think that's what. But we can think about this maybe later if we also have some idea to communicate with you about it.
Okay. Hi, Giovanni Moura. I'm with I'm with SIDN Labs and Delft University of Technology. And thanks for your presentation for summarizing such a long period of time in a such concise and yet comprehensive way. So I think it was very interesting. A bunch of stuff that you talked about, I only saw when I was in college. So it's very interesting. Thanks a lot for that. And I just wanted to say maybe there is an unintended audience in here. I think every student nowadays studying GitHub Tech should watch this presentation. So thank you very much for that. So thanks.
Adrian, you even have a gray beard.
Yeah, hi, Adrian Farrell. It's not my beard I'm wearing today. So yes, thank you for this. It's really good, and it's also a lot of fun. Train wrecks are great. We like watching them. I'm interested in how we extract the lessons from the stories, because it seems to me that the people who committed the sins, the people who designed the protocols, did not actually intend to create protocols and situations where networks crashed. And so the next generation of protocol designer also does not intend to do that. And they look at all the stories and the history and they say, well, I'm not doing that. But what they're missing is how to get there. So if and when and whoever writes this up, it needs to not just be this is a story, but also how do you learn the lesson from each story as you design a new protocol? And that's hard.
Yes.
Radio Folk, Deutsche Telekom. Well, okay, my beard is not yet as white as Ross's, but I know the date when they will force me to retire, at least from the current job. Let me be a little bit of a wise guy and try to raise 2 example points for, well, okay, where should we protect against things? And, well, okay, just knowing that design decisions does not actually help exactly tell what you should be doing against them. As my area of work has been for a couple of years essentially BGP, I'm essentially talking about stuff that John had. First I have the observation that some of the problems reported actually were figured out by Tim Griffin, doing very abstract algebraic work that obviously is something that some operator
staff is really very unlikely to do. Whether it is completely unexpected that the protocol designers don't use those tools seems to be a little bit more interesting. The veggie stuff is very kind of easily done in the algebraic domain. Figuring out in the algebraic domain how to control MED stuff and something like that is at least feasible, and someone at least has done the PhD on that. And kind of that PhD work kind of done as an exploration when the root reflector stuff was put in, should have actually done that. Well, okay, that's one example. The other thing is really something for operators, as we are in the ops area. And that is some of the things, John, you were talking about the implications of protocol extensibility and opaque data. I feel we haven't done sufficient work on identifying the responsibility in the operator domain of who is responsible for what is passed on, and applying sufficient hygiene to the data, because, well, okay, if you don't apply hygiene to the data that you are passing on or accepting, of course, well, okay, it's kind of useless. Actually, some considerations for protocol designers who are doing extensions about that hygiene being applied, well, okay, will be needed then, and also inspection of whether the vendor implementations actually provide the sufficient tools for the hygiene.
Thank you, Ross. Definitely, thanks a lot. This is valuable and valuable in having a long historical value information and discussion. Just one comment to Adrian. I wanted to respond to that, and I maybe will respond a little bit indirectly. So there is already an internet and its protocols. Maybe there could be a sequel to that, the history of the internet and its protocols.
Yep, I will try.
Yes, that will do.
Or I can run for mine. Who would have thought tactics was a good idea? Okay. Yay, technology. No, it's still loading. Yay! There we go. You have the clicker?
Yes, we do. Thank you. A quick overview of the state of the young in the industry, and the kind of a funny title to this is "How is Young doing?" And it appears that Young could do a little bit better. The reason for this discussion, we as IETF spent over a decade working on new ways of manageability, especially the model-based, lots of effort spent on model development, and if we realistically look into the industry and do a check of whether that is being used, deployed, it is actually not that much accepted. And
There are many reasons for that, and it's not a failure of, or maybe exactly it is a failure of the IETF that things are not moving ahead. It's a little bit of a view and some ideas to socialize with the community of what could we do with that. So first, the reality of how the management mechanisms look in actual deployments, that there is a trend that the industry is trying to develop something similar to what we have in a form and shape, but implemented in a completely different way. The parameterized templates which build into the hierarchies, and eventually that looks something like models, young models, but all of the tooling is based on various forms of interaction with the command line. This doesn't mean that the command line is a bad thing, and it's unrealistic to expect that that will disappear anytime soon. Command line is really needed as an exception mechanism for, well, basically for managing the exceptions. But all that nice view or vision of IETF that we will build the models which will be able to manage your elements, and not only elements, but the collection of elements, what we call service models. That is still a rather nice vision. However, the reality is a little bit different. It is not getting deployed that much. One of the reasons for that is education. This is a rather different paradigm shift to what the operations and the field operations are used to be doing for quite a long. And even here at the IETF, if we talk about models and the young and other things, it's not necessary that the operations community has enough of the insight of what that is and how that works. Even if they do, another aspect is tooling. You might think that if IETF creates a model, that solves the problem. No, model is just a tool. It's just a component into what is needed. And the tooling and all the workflow, how that is used, needs to be there, and the community needs to understand how to use that. This is an education and information dissemination question. So it's not enough to develop a model. There also needs to be some way of explaining why we think that if we do things this way, they are the right way. Or on the other hand, IETF needs to, model developers need to understand how those things are in fact used and what needs to be modeled in that. This is a saying that I sometimes use of a 2080. If we look at the industry overall, probably there are 20 large entities which are already using this nice vision. And for them, it works. For them, IETF as an organization is not needed. They are able, and not only able, that they are using similar or exactly the same mechanisms which are being specified here. But for the remaining 80,000, they are nowhere near having capabilities and abilities to do something like that. And therefore, solutions which work and which might be presented and advocated here, it's a big question whether they are applicable and practical for them. The open question is where IETF as an organization should be here, and what its position needs to be. IETF is good at working at fragments. Different working groups work at fragments which often don't even interact one with each other. And the manageability deliverables from IETF, yes, there are different young models. Do those models combine into the usable hierarchy? Do those models end up in being something like a system which can be taken and used? It's an open question and not necessary. If we look at alternative paradigms of modeling, and there is perceived conflict, or at least a disagreement between the IETF modeling way and open config modeling way. The fundamental difference and why one seems to be getting traction while another isn't is that open config works on a system. This is something that doesn't have the maybe very beautiful architecture as IETF models try to do, doesn't have very overarching coverage as IETF models try to do to cover absolutely everything. However, that is something which covers the majority of the practically needed tasks and actually can be used practically. Whether that is an ideal solution, hard to say, maybe not. On the other hand, it's absolutely not evident that that nice architecture, a nice overarching architecture coming from IETF side is also nowhere near ideal. One of the sources of this seems to be the lack of communication in both ways. Trying to understand what the problem is and trying to understand how the things are being used. Instead, quite often we end up in a situation where the vendor community is telling to the operator community how they should run things. And that is not necessarily the right approach. Certainly vendors have expertise on how their platforms work, but the platform is just a component. It's not a deciding factor. What is important is how that platform integrates into the end-to-end solution and how that end-to-end solution is managed as a solution, as an entity, and not as a bunch of separate network elements. There is also a need for communication in the other direction. The field is and operations communities, they are not aware of what IETF is doing and why they are doing things in what way they are doing. So it is about explaining what we are thinking and what's coming in the pipeline, at least to try to avoid the situation that IETF spent a decade working on something and then that something, when it is delivered, it doesn't get deployed at all because it doesn't solve practical problems. Was there a question or? So with this, it's an experiment to try to do something like a communication channel in the form of experimental working group or some other group, which tries to work on developing the guiding documents, not RFCs, but temporary guiding documents on how the protocol and well, component working groups need to be working. What are the priorities? What are the important things? And the most important part is how this should be matching together. I see Rob jumping to the microphone. Excellent. There's time for discussion. The reason for doing that, a young routing design team seem to have resulted in a good outcome. But routing is not enough. It's just a component. So if I want to use a practical system, it's much more than just a routing. And on the other hand, yes, there were workshops being done quite a while to check what is the state, what is needed. Maybe that needs to be rerun, as things simply have changed over the last 15 years. Questions, please.
Not so much a question, but a series of comments. I'm Rob Shakir. I do network management things at Google. I am one of the criminals behind the OpenConfig. What I would say, I stood up a few IETFs ago. I can't remember which one because there's beer in this week kind of clouds my memory. And said nobody cares that you're using Yang, and that's like the exact thing. So if you look at things like Ansible and Chef and Puppet that are taking things on, basically what people aren't really worried about the internal implementation of these things. They shouldn't be. We need to supply things where operators can actually use them. So at Google, the philosophy we're going with in this area is to open source as much of the work we're doing as possible, which is to get to the stage where somebody can log on to Git after they've read how to Git clone something, so they log on to GitHub and they can pull this down. Documents that explain like, oh, you might implement it like this, I don't think they're sufficient in this world. I think that we have to get to the stage where we have running code that folks can play with and that they can start to address some of their problems with. And we have to think about transition mechanisms. So in the work that we've been doing on gRPC interfaces to the device, GNMI, one of the key things that we did over the last year or so was this mixed schema implementation. So how do I move part of my config to a modeled output? How do I address the pain points so that I can still pull in all these static configs that are the boilerplate of how my NTP servers work and all these kind of things. But I can move to some of the some of the config being modeled such that I do have these correctness guarantees around them, and such that we have some portability. I think, well, you know, we've spoken a lot about the whether it's a working group or not, but I think focusing that, whatever that ends up being, on things that folks can actually use and solve practical problems and have code that people can pull, that's where we should be looking to progress this area.
So just to be clear, Yang is not the goal. Yang is tool. It's just a component. What is important is how that component can be used and whether the usage of that component solves practical problems. Solving a component, whether I can configure something, a fragment, is not a solution. It's just a component.
I agree, and I think if you look at what the vendor community has done in this space, which is if you go onto the Yang models repo that Tom Naidu started years ago, and look at the models that come out of, you know, they're auto-generated from vendor config databases. It is impossible to use these things. I think there's huge amounts of duplication. It's very unclear as to how to actually consume it. So we have, as an industry, focused on, oh no, the thing that we should have is these Yang models. And we've gone and found shortcuts to tick an RFP box that's actually moved us backwards. Because folks go and look at it, and then they have no idea how to consume it. And I say this just as background, as somebody that's now written 2 complete code generation tool chains for Yang, and a reference implementation for both the config and state side of telemetry and configuration. So I think I don't think that this message is clear to people that Yang models aren't a milestone along the way. They're not something that's usable and useful.
Beautiful. So one thing to observe is when you say Yang is only a tool, actually also the models are only tools. The use of the models is the actual goal, or well, okay, the crucial milestone. And yes, if the models are not usable, obviously you don't get there.
Exactly. So this is not a regular working group testing, this is an experiment, and that's still a question. And that will be done joint with other organizations, in particular RIPE and NANOC, and that's just an experimentation. So something more tangible probably would happen by the 103 timeframe. This is an early socialization of the idea, so any other comments, definitely welcome.
Here again, please do outreach to the various open source organizations, teams that are involved in this area. I think that having folks together in a room at RIPE or NANOC is a good thing to do. But we particularly have struggled with relationships with the IETF as to openness to feedback and ability to address things, especially in the language. And so I think starting to break down some of those discussions would be useful. Like OpenConfig is not bringing Yang models to IETF because it's not a productive use of the limited resources that we have.
Alexander Eriksson, if I might ask you a question. As I see, models are just another window to the device, like a CLI. Why do you find models more difficult to use than checkpoints, because I understand work really like CLI commands? So why do you find models more difficult to use?
Because the realization of Chef and Ansible is basically Ginger templates that have an execution environment around it. You provide some input, it maps it to the text output. Go and look at what you do when you get a Yang module. Like so I sat down when I first got involved in this space and said, oh, well, of course, there must be something that I can like take this and get some code to work with to start filling in a data instance so I can look at, I can send it to a device. 4 years later, 5 years later, I'm still maintaining a tool chain to do that because there are very few open source options. So the ease of consuming this is significantly simpler because you're really just using a bunch of templating stuff that essentially was designed for web development. And Yang doesn't have an ecosystem around it. I think one of the big learnings for me through this whole process has been coming up with domain-specific languages has a huge cost to it. and the tooling and the set of software that you need around it, and the functionality that you end up replicating is massive. So I think I significantly underestimated how much it was. So the Chef and Ansible thing is much easier because of the fact that there's code that you can run and you can just go and do it as a standalone developer. I mean, even commercial solutions, try and find somebody that will sell you something that is config generation involving Yang modules that doesn't also sell you professional services.
So that's probably that from my side. Thank you for the comments, and that concludes the OPSAWG part of the meeting. The next one is social.
Do you have questions?